Hello students! So this video here and this lesson is about midpoints. It's about midpoints and the midpoint formula. So guys, you might be looking at the word midpoint and you may be thinking to yourself, okay, midpoint. Sounds like a midpoint could be a point in the middle, and that's not necessarily wrong, guys. But again, we're gonna make sure that you know exactly what a midpoint is officially, and we're gonna make sure you know what they look like, how you can have a midpoint. Make sure you can recognize what midpoints are, what they look like when you actually have midpoints, opposed to just it looking like something is a midpoint. And then and of course we'll talk about a little bit more mathematical terminology that goes along with that, and then we'll look at a few examples. But again, guys, let's go ahead on and get started here. So first off, guys, a midpoint is a point that bisects. It's a point on a line segment. So first off, it's a point on a line segment that bisects that line segment. So again, folks, a midpoint is a point on a line segment that bisects that line segment. So now, some of you may be wondering, okay, you're saying that a midpoint is a point on the line that bisects that segment, but Mr. Starkey, what do you mean by bisect? Y'all, I'm so glad y'all asked that question. All right, so the word bisect, okay, it's a verb, and it means so again, bisect means to split a geometric figure. So it means to split a geometric figure, and it could be a geometric figure like an angle or like a line segment. All right, so it means to split a geometric figure into two congruent parts. Okay, so the word bisect means to split a geometric figure, and again, it could be a geometric figure sort of like an angle or line segment, but it means to split that geometric figure into two congruent parts. Again, guys, a midpoint is a point on a line segment that bisects that line segment. And again, when we say the word bisect, what we mean is that midpoint that's on that line segment, it splits that line segment into two congruent parts. All right, so guys, again, just in case you don't already know what the word congruent means. All right, so when we say congruent, what we mean is pretty much this, guys. Geometric figures, or maybe if we're talking about parts of geometric figures. So geometric figures or parts of geometric figures are considered to be congruent only if they have all of the same measurements. So again, your geometric figures or parts of geometric figures are considered to be congruent only if they have the same measurements. All of the same measurements. So again, folks, a geometric figure or parts of a geometric figure, they're only considered to be congruent if they have all of the same measurements. All right, so guys, since we're talking about midpoints and how midpoint, when a midpoint, pretty much we're talking about the fact that midpoint is a point on a line that bisects that line segment. Just kind of briefly, we're going to talk about some different geometric figures that can actually bisect a line segment. And so we're going to talk about that because it's possible that you may see some diagrams that have a line segment bisected in one of these four ways, and if that happens, guys, you will wind up having a midpoint as a result of having that line segment bisected. But anyway, we're going to look at 4 different ways or 4 different geometric figures that can bisect a line segment. Okay, so guys, those 4 different geometric figures that can bisect a segment are a line. Okay, that's the first one. A line can bisect a segment. Also, a ray. For those who don't understand or don't know what a ray is, I will explain exactly what that is in just a second. So a line, a ray. Also, another segment could bisect a segment, and of course the last of those 4 geometric figures is we could have a point that's bisecting a segment. So again, those 4 are a line, a ray, that's R-A-Y, okay, a line, a ray, another line segment, or a point. Okay, so guys, I've already introduced to you and defined those other 3 terms, but some of you may not know what a ray is. And so we want to make sure that everybody knows what a ray is and bring you up to speed concerning that. Guys, a ray is part of a line with only one endpoint that extends in one direction without end, and it has no specific length. And guys, we name a ray using its endpoint first and then one other point on that ray. So for you to name a ray, you've got to use its endpoint, okay, and you have to start off with its endpoint, and then you have to use one other point that's on that ray. And again guys, a ray is part of a line with only one endpoint. You can see that endpoint right there. Boom. Endpoint is D in this one that I've got drawn right here for you. So it's got one endpoint, and it extends in one direction. You can see which way it's extending, right? Okay, without end, so it won't end when it's extending in that direction, and it has no specific length. The reason why it has no specific length is because it will not end when it's extending in that one direction. So if it will never end when it's extending in that one direction, it means it has no length. Alright, but anyway, guys, so that's what a ray is, and that's how we can name a ray. But again, guys, these are the 4 different geometric figures that can bisect a segment. And again, folks, the only one of those that we had not already previously defined in one of our previous lessons was ray. Okay, and that just so happens to also be my brother's name. Hey, my oldest brother's name. All right. Also, guys, when you're naming a ray using that endpoint and one other point that's on that ray, you've got to use that symbol on top of it. So again, that's different from when we're doing a line. Uses this symbol on top, right? So that's the symbol you use for a line. And I'm going to erase that in just a moment. But again, that's the symbol you use for a line. This is the symbol. Oops. Well, if I can get it straight enough, that's a little bit better. A little bit. Messed it up again, but it's gonna have to work for right now. Y'all know what I'm trying to do. That's the symbol that you use on top if it's a line segment. And then of course you can see how that symbol that we're using right now for array is different from those 2. And again, I'm going to erase these two. Again, that's not anything new there. Oopsie. Yep. Reckon that ain't gonna get back down. Okay, so if you look here at these figures or little diagrams that I have here, you see a line that looks like it's going through a segment AB. You see an array that looks like it's going through or intersecting that segment AB. There's two different versions of it where you have array that is intersecting or going through or splitting a line segment. Then you got one here where you got a segment, another segment that is splitting this segment AB. And then you got here in this last one here a point that's splitting that segment AB. Now, guys, if you were looking at all of these, let me say, if I were to ask you a question, is F in all of these? So you see what I got here and remember, guys, we said that when you're naming a point, you just name it a capital letter. So the point in all of these that represents point F. Now I know I only have like one of them where you can like visibly see like for real see that point F, but again, y'all, there ain't many options as to where point F could be here, right at that intersection point. Not too many options where we could be talking about point F. But anyway, yeah. So if I were to ask you guys, is point F in all of these little diagrams that I have here, is point F a midpoint? Does it look like point F is a midpoint? Does it look like point F in all of these diagrams that you see here? Does it look like point F is bisecting or splitting those segments into two congruent parts? Most of you would probably tell me that it does indeed look like point F is a midpoint for all of these, and you wouldn't be wrong by saying that point F looks like a midpoint. So again, guys, there's a reason why I asked that, because guys, we cannot, I repeat, we cannot go based on how it looks. We cannot go based on how it looks. Just because it looks like a point is a midpoint does not mean that a point actually is. And folks, I'm telling you specifically, do not assume that that point is a midpoint just because it looks like it's a midpoint. Just because it looks like it splits a segment into two congruent parts. Do not assume that it is a midpoint. Okay, guys? The only way that you will know for sure that you're going to know, like for sure that a point is a midpoint, is if you are specifically told that. So in other words, if you got a certain situation where they tell you, like in words, or pretty much if they tell you that a point such and such is a midpoint, or if you make some type of logical conclusion, yes, I'm talking about logic in a math class. If you make some type of logical conclusion that a point is a midpoint, and the only way that you're going to make some type of logical conclusion that a point is a midpoint, as of right now, my students in my classes, the only way you're going to make some type of logical conclusion is that a point is a midpoint if they don't tell you specifically that it's a midpoint. The only other way for you to tell that it would be a midpoint in my class right now would be if you see congruency marks, or if you see like specifically if you see like the same lengths for those two segments. Okay, folks, this is an FYI moment, very important for your information. Okay, remember, do not assume. Please do not assume just because it looks like Okay, you see where I got that point right there? Select it. Just because it looks like a point is in the middle of a line segment, and it looks like that point, it may look like that point is bisecting that line segment, splitting it into two congruent parts. Do not assume that, folks. We should only consider a point to be a midpoint of a segment if we are given that information, like for instance, if we're actually told, or guys, and again, this is if you're in my class, at our school, enrolled in my class, okay? Either if you're given that information, number one, then you can consider that point to be a midpoint, or number two, if you see definitive proof in the diagram, such as congruency marks. And for those who don't know what congruency marks look like, guys, for a line segment or for types of segments, they'll sort of look like little tick marks. But again, guys, they should be matching tick marks like this. It could be just one single tick mark and then a matching one in another segment. It could be like two little tick marks. Like, oops, yeah, don't want that to look too sloppy. It could look like that, like two little marks, okay? Or it could be like three little, as long as they match, it could be like three little tick marks. But those are congruency marks, okay? Y'all saw the difference between all of them? It could be like four of them. You see that? Look at that. As long as they match. Those are congruency marks. Telling you that those two segments, right there, you see the congruency marks? Telling you that those two segments are congruent to each other, okay? If they match. It could be four tick marks that's matching in both of them. It could be three tick marks that's matching in both of them. It could be two tick marks that's matching in both segments. It can be just one tick mark that's matching in both segments. But anyway, those congruency marks, okay, for segments, or depending on what type of figures, it could be what type of geometric figure, congruency marks, it could be congruency marks for a side, like if it was a triangle or something like that, or a rectangle or quadrilateral or something like that. You could see congruency marks that look like that in the sides. That would be telling you that those side lengths of that polygon are congruent. But anyway, so those are congruency marks, right? So if we see definitive proof in the diagram, like those congruency marks, or guys, it could actually be written in the diagram where you see equal segment lengths. Okay, so that's three things that can indicate to you, like sure enough, that can indicate to you that we really have a midpoint that you need to look for. Okay, either you'll be told that information, or you should see definitive proof in your diagram, congruency marks or equal segment lengths written in the diagram. Okay, all right. Now I think we are ready to start looking, sure enough, at our midpoint formula, okay? Now that we've gone through this basic information. I take that back. We're going to go through just a few little examples dealing with midpoint and kind of tying together. It is sort of kind of tying together what part of what we did with the segment addition postulate, and sort of kind of not to. I'll show you how it can sort of tie together with the segment addition postulate, but we don't have to write it out as segment addition postulate. But again, we're gonna look at a few examples, 2 or 3 examples with just kind of midpoints with segments, before we actually look at using the midpoint formula. Because again, guys, I want you to be prepared for everything that comes your way. Whether I'm assigning you problems like this and again, I'm talking to my students enrolled in my class. Whether I'm assigning you problems like this, or whether you'll see problems like this on your final exam. Again, I want you to be prepared. So yeah, all right, we're gonna look at a few examples of that before we look at the actual midpoint formula. All right, so here we go. Example 1. All right, so you guys see that diagram right there? Y'all see that? Y'all see them 3 points, C, A, T. All right, and you see those marks that you see right there, those little tick marks. Well, we just said that those were congruency marks, right? So that means that this segment here that you see on the left side, right, CA, that means that one is congruent, or it has the same measure as that segment on the right side, AT. CA and segment AT are congruent, and we know that because we see these congruency marks on this diagram. Okay, all right. All right. So again, they say here find X and Y if CT, and again, guys, we know that we're talking about the length of segment CT. If the length of segment CT equals 6y minus 8, and CA, and we're talking about the length of segment CA, equals 3x plus 23. All right, so before we look at any of those, before we look at any of those algebraic expressions that we were given there, let's just look at the segment that we've got just real quick, right? So based on what we just looked at, right, where I told you that if you have those congruency marks there, that means that they're congruent, right? Those matching little tick marks. So if these two parts right here are congruent, that means that point A is bisecting this segment CT, right? So if point A is splitting segment CT into two congruent parts, yes, congruent parts, because we have congruency marks, right? All right, so that means that point A is clearly a midpoint. Point A is a midpoint. It splits segment CT into two congruent parts. Congruent. See, congruency marks. All right. So again, guys, where they told us that this part here was 17, right? If this part is 17 and this other part is congruent to it, and again we talked about the fact that congruency or that your parts of geometric figure are only congruent if they have the same measure, right? So if these congruent parts are supposed to be congruent, that means they need to have the same measure, right? So if one of them is 17 units, or if the length of one of them is 17, that means that the length of the other one has to be 17. Yeah, that's what congruency means, that they have the same measure. All right, awesome. So if that one's 17, this one's 17. Great, we know that. So if both of these congruent parts are 17, what does that mean for the whole segment? Okay, I said I would tie it into the segment addition postulate, right? Not that we have to write out the segment addition postulate, but again, I said I would. I'll erase it afterwards. But right, if we did the segment addition postulate and if we wrote out that, right, the length of segment CA plus the length of segment AT is supposed to be equal to the length of the whole segment CT, right? All right. So the length of segment CA is clearly. I said clearly, Charlie. All right. It's clearly 17. All right. And the length of segment AT is clearly 17. All right. So if that's the case, 17 and 17, when we add those two parts together, it's got to give us the length of the whole thing, which is, that means that the whole thing has to be 34. All right. So CT has to be 34. Okay. And CA has to be 17, right? Well, we didn't necessarily know that at first, but we were able to figure it out because we had those congruency marks there, and because we know how to use common sense when we know certain information. When we know certain information, we can figure out other stuff by using a little bit of common sense, and we call some of that logic, right? All right, anyway, awesome. All right, so I am going to erase what I have right here because we don't necessarily need that, but I'll leave it written for right now, only because, and actually, yeah, we don't have to have that written at all. I am gonna erase it. I'm just gonna write out up here that we had the whole segment length there. That whole segment length was 34. I'm gonna erase this. Yeah. All right. Cool. All right. So let's go ahead on and let's solve and let's figure out what it is they were actually asking us to find. Right. So in this problem, since we have used our logic and used some common sense, and applied what we knew about those congruency marks, and about the fact that this point A was a midpoint. So after we did that, let's go ahead on and figure out what they're asking us to find, right? So in order for us to find x and y, guys, we got to use those variable expressions that we were given. So let's do that. So we were given. Give me a second here. Give me a sec. Just 1 second. All right. So if we were going to find, if we were going to start off by finding y, right? So we were given the variable expression that had the y in it was CT. So the length of segment CT equals 6y minus 8. Okay? So we now know that the whole length for segment CT is 34, right? So technically CT, we can replace that with 34, right? Because yeah, we know that. Yeah. Alright, so CT is 34. And so now we just got a regular equation where 34 equals 6y minus 8, right? Okay, awesome. Alright. So all we gotta do there is solve that. Add 8 to both sides, add 8, that's gonna be 42. And then you have to divide that 42 by 6 to finish solving for y, right? Okay, great, awesome. Divide by 6, divide by 6. That means that y equals 7. Okay. Alright, that's the first part of what we were asked to find. Alright, so now that we know that y equals 7, we know that y equals 7. Alright, that's that part. Let's go ahead on and let's figure out what x is. Eesh, okay. Let's try that again. There we go. And let's find x. Alright, so the variable expression that had x in it was the expression CA, right? Or that the length of segment CA. So the length of segment CA, they told us, was 3x plus 23. Alright, so we had already figured out that the length of segment CA had to be 17. Alright, so again, segment CA is clearly 17. (17) equals 3x plus 23. Okay, alright, so that's the regular equation. All we gotta do is solve. Let's subtract 23 from both sides. Subtract 23, that gives us negative, wait, see, I was thinking and writing what I was thinking. That gives us negative 6. Alright, And then when we do that there, negative 6 is equal to 3x. And all we got to do to finish solving for x is divide by 3. Okay, so that means that x equals negative 2. Cool beans. Alright, I don't like the way that looks. Let's try that again. I said x equals negative 2. Okay. Alright folks. Alright, so that takes care of example 1 there. Alright, we're going to look at a few more examples. Sort of similar to that, not exactly the same. Before we talk about the midpoint formula, because I want you to have seen what types of problems you could be exposed to that have midpoints in them. Whether the problems that I'm assigning you for this particular lesson, my students enrolled in my classes at our school, whether the problems that I'm assigning you for this lesson are exactly like these examples or not. I want you to see what these examples look like and how to do them, because you might see this in your final exam or later on as well. So yeah. Anyway, we're going to look at a few more examples, and then we're going to talk about the midpoint formulas. Okay, so here's example 2. Point U is the midpoint of segment BG. Okay, so here they're asking us to find BG, and we know that they're talking about the length of segment BG. Find the length of segment BG if BU equals 7x plus 3 and UG equals 3x plus 50. Wait a minute. Some of you guys are probably thinking, okay, Mr. Starkey, hold up now, Mr. Starkey. In that last problem that you showed us, you had a diagram for us. Look here now, Mr. Starkey. Why you ain't got no diagram? Huh, Mr. Starkey? Why you ain't got no diagram for me? Alright, so we don't have a diagram. Okay, we've done problems where there wasn't a diagram drawn for you. When we talked about the segment addition postulate, there wasn't a diagram drawn for you on some of those examples and some of those problems that you had to do. Okay, so it says that point U is the midpoint of segment BG. So tell me that you don't know how to draw segment BG. Please tell me you don't know how to draw segment BG with the two endpoints BG. I wish you would try to tell me that you don't know how to draw segment BG. Don't make me laugh. Anyway. Alright, so they say we got segment BG, right? BG. Okay, I don't like that. I don't like that in black. Alright, let's try it in a different color. Try that. Let's try that again. That looks so much better right there. Look at that. Hey. Alright, enough. Didn't mean to erase that. Alright, so you got segment BG. Cool. And it says, alright, let's try to put a point there. Alright, just put any point. Don't matter. Cool. Alright, it says you got segment BG where the two endpoints of it are B and G. Yes. Close enough. Good enough. BG. Segment BG. And it says point U is the midpoint of segment BG. So, guess what? Point U is the midpoint of segment BG. Now, guys, that spells bug. 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 That's so funny. Who came up with that? Alright, anyway. Guys, again, folks, it says point U is the midpoint of segment BG. Now, when you see that point U, what did I tell you in our little FYI? Didn't I tell you, do not assume that a point is a midpoint of a segment just because it looks like it? It might look like point U is a midpoint. It might look like point U bisects this segment. It might look like point U is splitting this segment into two congruent parts. But what did I tell you? Unless they specifically tell you, and now folks, they did tell you here that point U is a midpoint, so we know that it is. But guys, when we're doing a diagram, we want to put something on that diagram specifically that lets other folks know that this point is a midpoint, right? So make sure that you do that. So we need to put up here some little tick marks, congruency marks, right? Matching congruency marks that look like little tick marks up there. Okay, that's what we need to do right now. All right. Okay, so now we've got our diagram drawn, and so folks, they told us that they wanted us to find the length of segment BG. So they said find the length of segment BG if and then they give us this other information. If BU equals 7x. Okay, give me 1 second now. 1 second, 1 second. Alright, so if BU, let me kind of put that, I ain't got to put it separate, but I am going to. If BU is 7x plus 3, right? And UG is 3x plus 15. Alright, so again guys, they told us that information already. Gotta move that real quick, give me a sec. Alright, they already told us that information. Now, folks, here's the deal. Here's the deal. Alright, here's the deal. If they gave us these congruents, or they told us that U is a midpoint, and guys, by us knowing the definition of a midpoint, the fact that it means that point U splits this segment, splits the whole segment into two congruent parts. Guys, if these two parts are congruent, that means that these two parts have the exact same measurement. So again, if we know that these two parts are congruent, that means that we know that those two parts have the same measurement. Okay, again folks, those congruent parts have the same measure. That comes by knowing the definition of a midpoint and knowing what congruent means. If a midpoint splits a segment into two congruent parts. But anyway, if a midpoint bisects a segment, all right. So those congruent parts have the same measure. I'm writing it out, not that I have to write it out. But so you see where we going with this. Those congruent parts have the same measure. So if those congruent parts have the same measure, that means that technically the length there for that first segment has to be equal to the length for that second measure, right? So that means that and it doesn't matter what order we do it in, that means that 7x, oops, give me a sec, that means that 3x plus 15, that part, has to be equal to the 7x plus 3. Alright, so that should make sense if they've told us that point U is a midpoint. And if we know that a midpoint splits it or bisects it, which means that it splits it into two congruent parts, we take that meaning of it having congruent parts, and based on this example, based on the information that we had, those two algebraic expressions, we would have to set those two algebraic expressions equal to each other in order for us to solve for x. Now guys, we're going to solve for x here, but remember folks, remember what we were asked to find. We're going to have to solve for x But remember what our final goal is and what they're asking us to actually find. All right, so let's go ahead on and solve for x here, because we're going to have to solve for x in order for us to find the length of segment BG. Okay, let's solve for x. Let's do this. Let's put all our variables together on one side of the equation. Let's go ahead and subtract 3x minus 3x on both sides. Put that together. All right, cancels out there. That leaves us with 15 on the left side. All right, let's do that. 4x plus 3. Awesome. Let's go ahead on and get all our constant terms on the same side of the equation. Let's subtract 3 on both sides. All right, that cancels. That leaves us with 12 here. Cool beans. 12 equals 4x. The only other thing for us to do to solve for x is to divide by 4 on both sides. That cancels on the right side of the equation. That leaves us with the fact that x equals 3. Okay, so we've got the x equals 3. Remember, folks, we're not done, because we were not asked to find x. Even though we have to find x in order for us to figure out what they're asking us to find, we were not asked to find x. We were asked to find the length of segment BG. So again, folks, let's make sure that we find what they're asking us to find. The length of segment BG. Okay. Looks a little bit better. A little bit better. Alright, cool. Remember, folks, that the length of segment BG, okay. Technically, folks, if we put that together, and again, folks, here's another place where our segment addition postulate comes in place, right? So the length of segment BG, is that whole segment. It's the whole segment from B to G, and we know that if we use the segment addition postulate there, the length of segment BG has to be those two separate parts added together. So it has to be 7x plus 3. Oops, give me a sec before I do that. It has to be the length of segment BU plus the length of segment UG, right? Which means that it has to be 7x plus 3 plus 3x plus 15. So again, the length of segment BG is those two parts added together. And so if we're going to find that length, we got to plug in the value of x there for our in this equation to figure out what the length of segment BG is. So that's 7 times, okay, and we're going to replace x here, of course, with 3. So that's 7 times 3 plus 3 plus 3 times, and we're going to replace x here, plus 3 times 3 plus 15. All right, so let's go ahead on and work that out. Work it out. Work it out. Work it out. Equals, all right, so 7 times 3 gives you 21. Cool. Yeah, that's sloppy. I apologize about the sloppiness, guys, but yeah, it's just gonna have to be a little sloppy right now. I'm sorry. It's just gonna have to be. My bad. Sorry. 21 plus 3. All right, 3 times 3 gives us 9. All right, that's also plus 9 and then plus 15. We put all of that together. 9 plus 15 gives us 24. 21 plus 3 gives us 24. Awesome. All right, so all together, all 4 of those added together gives us 48. Great. So we know that BG equals 48. And that's what we were asked to find in example 2 here. So the length of segment BG is 48. That's our answer. All right, so again, guys, we had to use what we knew about a midpoint. The fact that it was congruent, we had to set up an equation there, and we had to solve that for x, and then we had to plug in x to find what they were actually asking us to find. We're going to look at one more example like this, and then we're going to do briefly, very briefly, the midpoint formulas and just 2 examples with the midpoint formula. But before we do the midpoint formula, we're going to look at one more example like this. All right, so here we go. Example 3. You got a point O, and they're telling you the point O is a midpoint of segment MOP. Point O is a midpoint of segment MOP. Again, folks, some of you guys might be able to just look at it like that and just automatically know how it looks or whatever. I happen to be a type of visual person, and you know I'm good at math. I just so happen to be I find it easier to do it when I'm looking at a diagram myself. Y'all might not be in a position where you want to draw a diagram, but I'm just letting you know it's probably going to be easier for you to look at and easier for you to do if you go ahead and draw a diagram. I'm just saying, I'm just trying to keep it real. You know, don't blame me. I'm just trying to keep it real with you. I'm trying to keep it 100. That's all I'm saying. You know. Anyway, all right. That's all I'm saying. That's all I'm saying. Just trying to say, y'all, you know, shoot. Alright, so we got a segment MP, and they tell us that O is the midpoint of that segment. So we got a segment MP, O is the midpoint. Let's go ahead on and put our point there. Remember, folks, that if we've got a diagram and we want to sure enough indicate that we've got a midpoint on that diagram, make sure that you put like some congruency marks up in there. Okay, and that lets us know that we got that those two parts there are congruent, and because those two parts there, or those two little segments is congruent, we know the point O bisects this segment. We know the point O splits the whole segment into two congruent parts. You can see the two congruent parts, so there's no question about whether or not point O splits it into two congruent parts. Anyway, that's just the definition of midpoint, right? But anyway, so we've got this thing drawn. They tell us to find the length of segment OP if MP equals 15x minus 8 and MO equals 4x plus 10. Alright, so they give us certain information. Again, they give us some variable expressions here, and we should kind of be able to work with that. So again, they tell us that MP, so the length of segment MP, the whole thing from M to P, they tell us that segment length is, excuse me. Alright, they say that whole length there ain't much better. I reckon. Yeah, 'cause I ain't really do too hot. There we go. Alright, 15x minus 8. Alright, and then they tell us that MO, the length of segment MO, right there. Yep, segment MO, they tell us is 4x plus 10. Okay? Alright, so guys, we got two ways of thinking about this here. Well, I'm going to go ahead on and just write it out like this. Because, I mean, it's the same thing, really, if we know what we're doing. Alright. So, again, folks, they tell us that point O was the midpoint, which meant that, again, point O split the whole segment into two congruent parts. So the whole segment of MP was split into two congruent parts. Guys, if this part on the left was equal to 4x plus 10, guess what? Guess what about the part on the right? If the part on the left was equal to 4x plus 10, guess what? Did y'all guess it? Did you guess it? I can't hear you. I can't hear you. I think you guessed it. You guessed it, didn't you? Yeah, you know it. You know it. Yeah. Yeah. Absolutely. Yeah. Alright, so yeah, absolutely, guys. And again, just gonna write that out. Since MO, since that segment for MO is, oh, and by the way, I wanted to even though we will talk about that later as well. Also want to introduce you guys to this symbol, congruent to OP. Okay, so that symbol right there, it looks like an equal sign with a little squiggly over it. That means congruent to. That means that the segment MO is congruent to segment OP. Alright, so since those two segments are congruent, segment MO and segment MP, then that tells us that the length of segment MO equals the length of segment OP, right? So again, since they're congruent, that means that those two segments have to have the same measurements. In other words, the length of segment MO has to be equal to the length of segment OP. And again, guys, if the length of segment MO was 4x plus 10, that means that the length of segment OP, again, folks, has to be the same thing. All right, that just should be sort of common sense. If we're saying that those two parts there are congruent, and we know the congruent means that they have the same measure. So if one of them is 4x plus 10, the other one has to be 4x plus 10 as well. All right, so both of them clearly are 4x plus 10. So guys, if we know that, and here's another place for us to use the segment addition postulate. That we talked about in our most recent or previous lesson. Oh, that ain't how you spell postulate. Alright. Okay, so if we use our segment addition postulate, if we write that out, the whole segment MP, the length of segment MP should be equal to the length of both of those parts when they're added together, and we know that one of those parts is MO, which is, oops, hold on, let's write it out like this first, should be equal to MO plus OP, right? So the length of the whole segment MP should be equal to both of those two parts added together. And again, folks, they told us, oops, where we at? Alright, we got to hurry up, yeah. They told us that MP was 15x minus 8. They told us that MO was 4x plus 10. And again, we used logic, common sense, whatever you want to call it, knowing that those two parts were congruent based on us knowing the definition of a midpoint. That means that both of them technically had to be the same length, which was what we were given, 4x plus 10. Alright, so we've got this equation, and let's go ahead on and solve for x. Remember, folks, that even though we do need to solve for x, that's not our end game. That's not the very thing that we were asked to find. Even though we have to find it, it's not the main thing that we're asked to find. So after we find x, we're not done until we find what they're asking us to find. So let's go ahead on and let's solve this. Let's solve it for x. Let's go ahead on. Let's combine our like terms here on the right side of the equation. Let's put those together that are on the same side of the equation. 4x and 4x gives us 8x. Alright, let's hurry this up because we ain't got much time. 10 and 10 gives us 20. Because we got to go ahead on and get to the midpoint formula and two examples with that. Alright, let's get all our variables on one side of the equation. Minus 8x minus 8x. That gives us 7x. Awesome. Alright, we still got the minus 8 over there. The only thing left on the right side is plus 20. Okay, let's get all our constant terms on the same side, the opposite side of the equation. Let's add 8 to both sides. Alright, that's going to leave us with 7x on the left side. It's going to leave us with 28 on the right side. The only other thing left for us to do to finish solving is to divide by 7 here. Close enough. Close enough. Don't have to be. Divide by 7. X equals 4. So again, guys, we've got the value of x, but again, that's not what we were technically asked to find. Remember, we were asked to find the length of segment OP, and that's what we need to do. All right, so again, OP was equal to 4x plus 10, and we need to plug in our x value that we just got. So that'll be 4 times. Okay, and we're going to replace x with what we just got, that value 4. All right, so that's 4 times 4 plus 10, and then we know that 4 times 4 gives us 16, so that's 16 plus 10, which is 26. All right, so guys, again, sometimes you'll be asked to find just one of those lengths, like what we found here. We found that one length was OP, right? We found what they were asking us to find. OP, wow, yeah, okay, which is 26. We found what they asked us to find. But again, folks, sometimes they'll ask you to find not only just one length, but they'll ask you to find the length of all 3 segments. So if what we just found was segment OP, and that was 26, and segment MO had to be the same thing, 26, right? Then the whole segment there, segment MP, had to be 52, right? So once you, technically with a midpoint, once you find one part, technically, it doesn't take much to figure out the other 2 parts, okay? But again, we have found specifically what they were asking us for in this example. We have found OP. All right, folks, next up, we're going to look at exactly what that midpoint formula is. I'm going to go ahead on and erase this right here. We're going to look at exactly what that midpoint formula is. Not only just what the midpoint formula is on a number line, but also what the midpoint formula is for when we have it in a coordinate plane. So we're going to look at the midpoint formula for on a number line and the midpoint formula in the coordinate plane. All right, right now. Okay, so guys, there's only one midpoint formula, but again, guys, so let's just look real quick. If you were looking at a number line, you see this number line that's on the left side here in this little figure here on the left side. You see a number line, and you see they've got 2 points, a point at the value of -4 and a point at the value of 8, right? So if you wanted to find the midpoint between, let's just say between -4 and 8, again the formula to do that, and again this one here is just for like a number line, okay? The formula is sort of similar to what you would do if you were just taking the average of those 2 values, where you add the 2 numbers together and then divide that by 2, right? So if you were going to do that, you would take that value of -4, you would add it to 8. Again, folks, you would need to do that first at the top of the fraction. Simplify that first. -4 plus 8 gives you +4, okay? And so at the top of that fraction, that simplifies to +4. You want to do that first. Simplify the top of the fraction first, and then divide that number by 2. So that would be +4 at the top divided by 2, and +4 divided by 2 gives you 2. And so, guys, the midpoint there, and I don't know why they didn't put that up there. That the midpoint there would be 2. I'm going to put it there anyway. So the midpoint there would be 2. All right. Now that's not exactly what you'll be looking at, even though it's based off of that. What you'll be doing is midpoint on the coordinate plane. And so, guys, that midpoint on the coordinate plane is very much so based off of that. Guys, on a coordinate plane, you've got two different components. You got your x components, right, which is like from left to right. So think of it as if you had a horizontal number line, and one of the x and one of the values was x1 and the other one was x2, right? So you'd have to find the midpoint for those two x values, right? So you see that with the x1 plus, let me zoom in a little bit. Let me zoom in just a little bit so you can see what I'm talking about, right? Okay. So again, guys, you would have to find the x value, sorry, the midpoint for those x values, and I'm about to wrap this up real quick and show you two different examples. The first example is going to be super quick, and because we really don't have a whole lot of time. I got to get about in here. Yes, sir. Ooh. All right. So let's say that again, you had to do a horizontal number line that deals with the x values, guys, and then again, let's say that you also had like a vertical number line that's specifically dealing with your y values, right? So those y values, you also got to find the midpoint with the y values, and again, guys, one of the y values is y1. And the other y value is y2, okay? So again, you got to find the midpoint between the two x values, and that'll give you the x value of the midpoint. So again, guys, the whole midpoint is going to be written as an ordered pair, x and a y. The x value of the midpoint, guys, is going to come from finding that midpoint between the two x values, which is shown right there. And the y value of the midpoint is going to come from finding the midpoint between the two y values. All right, we're going to do a quick little examples because we really gotta have time for these videos to upload, and I don't want to have this alarm going off on me here. Alright, examples coming up real quick. Okay, folks, example 4 here says find the midpoint of the segment with the following endpoints. So again, guys, if you're given two endpoints like this, let me go ahead on and let you know. Okay, so again, guys, you're given two endpoints. You got an x1 as one x value, you've got an x2 as the other x value, right? Okay. You got a y1 as one x value, as one y value, and you got a y2 as another y value, right? So if you're going to do that and find the midpoint with this, oops, hold on. I'm just going to write m as being short for midpoint for right now. The same way they got an M right there. You see that? You see that? Awesome. I'm going to erase that or get rid of that. All right. Excuse me. All right. So that's M equals, and again, guys, when we write it out, it's going to be in the form of X, Y, right? It's going to be in the form of an ordered pair. But again, folks, if we do it the way that it's supposed to be done, we add together the two X values. And so again, folks, I'm not going to take that time to write the formula in here because you can see the formula right there in the little diagrams that are above. So I'm not gonna write it here, okay? And we're just gonna plug it in. All right, we got -5 plus 1. Those two x values got to be added together and divided by 2, and then you got for the y values 7 and 4. So the two y values have to be added together and then divided by 2. So if we simplify that, and if we do what's on the top of the fraction first, at the top of the fraction, -5 plus 1 gives us -4, and -4 divided by 2 is technically -2. And go ahead on and simplify that. Awesome. All right. For the y values, when we simplify that part, 7 plus 4 gives us 11, and 11 divided by 2 gives us 5.5. You can either leave it as that fraction of 11 halves, or most of you will probably just want to divide it. I don't know why. It's the same thing as just leaving it as that fraction, 11 halves. But anyway, that's the midpoint here. If we had those two points, that would be our midpoint. using that midpoint formula that you see right there. All right, guys, we're gonna look at one more quick little example, and okay, yeah, I wanted that to do this little thing right here, but apparently it didn't want to do that. Okay, one more little example. I'm gonna have to try to hurry through this because I don't want to be stuck here with this. With it's late, y'all, and they set this alarm. Okay. Okay. All right. So guys, here we got example 5. This one is slightly different. Okay. We got here. They're asking us. They're telling us that the midpoint of segment TY is 0.0. And 0.0 is 3, -7. Guys, if you want a visual with that, and you really don't have to have a visual with it, but if you just want a visual for it, fine. That's fine. But again, you should know and remember how to do that little visual there. If you just want a little visual, the segment. So it says you got a segment TY here, and the midpoint of that is supposed to be what? 0.0. Oh, that spells toy. Okay, 0.0. All right, and it says 0.0 is 3, -7. And they tell us that the coordinate of T, the coordinate of point T. Now, guys, of course, if this is on a coordinate plane, of course, guys, it would actually be like 3, -7 would be down here somewhere, right? Of course, but I mean we don't really have time to really draw it out like that. And TO, I mean point T, if that is what they say 1, 1, then of course point T 1, 1 will be like right there, right? At that point 1, 1. And but anyway, guys, point T, 0.0, right? Like that, T and O, or I had that opposite, but 0.0, point T. But again, folks, if you just wanted a little visual, all right. But anyway, what we will need to do in this particular problem, guys, is we're going to have to actually write out 2 separate equations. And let me explain what I mean by write out 2 separate equations. So guys, we've got this good little fancy formula here, right? And so, guys, with this, they told us what the midpoint was. They've already told us that the midpoint is the point 3, -7. Okay. So if we know that the x value for the midpoint is 3, since they've told us that the x value for that midpoint is 3, what that means, guys, is that 3 is the exact same thing as x1 plus x2, right, divided by 2. So 3 is the same thing as that, okay? Now, folks, the only part of this that we don't know right now is the coordinates for point Y. But I will tell you this, guys, if we've got our midpoint, which is, the x and the y there, for what we've already got, 3 and -7. If we've got that midpoint and we want to, we gotta hurry up. All right, this part here, be our x1. The x value that we will be trying to find will be x2, folks. The part that we don't know for that x value will be x2. I'm trying to show you this very, very quickly. I apologize if it's too quick for some, but we almost out of time here. Cause the x value that we do know for the endpoint. So for this endpoint 1 here, I'm trying to do it where you can kind of see what's going on. Endpoint 1 that we're given will be x1 and y1, okay? And endpoint 2 is the part that we don't know at this moment, okay? So endpoint 2, we don't know what that is, and so yeah. All right, let's go ahead on and plug in what we need to plug in here. We're gonna have to make 2 equations, and I'll try to show that without making this too sloppy, guys. Yeah, yeah, okay. I'm not gonna rush this because we should be able to get through this where I can at least get the basic video uploaded. Yeah, okay. Alright, so alright, so what we want to do is make 2 equations. One for the x value and one for the y value. One for the x value, one for the y value. Make 2 equations, guys. Okay. Okay, so the equation that's dealing with the x value and the equation that's dealing with the y value. I know that may not even look like an and right there, but that's okay. All right, so 2 equations that we're gonna make. So the y value of the midpoint, we know that is, sorry, the x value of the midpoint is 3. Okay, so we know that the x value of the midpoint, and I apologize about how sloppy this is. It wouldn't usually be that sloppy, but guys, I'm on a tight limit here of time. Yeah, so it's all good. All right, the x value there is 3 for that midpoint, and again, guys, the part of the formula, the part of the midpoint formula that determines that is that x1 plus x2 divided by 2, right? I'm going to write that real quick, but then I'm going to substitute those parts that we need to substitute. I'm going to make that even smaller. Oops, didn't mean to make it that small. Okay. Alright, x1 plus x2 divided by 2. Wow. Okay. Alright, and I want to substitute those parts that we do have. So we know that x1 here is 1. So that's 1 plus x2 over 2. Alright, so that equation that we've actually got for the x values is 3 equals x1. Sorry, that's 3 equals 1. Okay. 1 plus x2 divided by 2. And we need to solve that equation to find the x value that we're looking for. The x value of the other endpoint. Alright, so when we try to solve this equation, guys, we're going to need to multiply both sides of this equation by 2. Multiply by 2 on both sides of the equations there. Alright, so if we multiply the left side of the equation by 2, and technically when you multiply the right side of that equation by 2, it's going to cancel out that 2 at the bottom there. Alright, so right there, 2 times 3 on the left side gives us 6. We still got 1 plus x2. And again, guys, if we solve that by subtracting 1 on both sides, we get that the value of x2 there is 5. I do apologize about how sloppy this is, guys. Again, we short on time. Alright, the x value there. So we've got half of our answer right now, because again, guys, what we're looking for is the whole, wow, okay, I was trying to do that, but it's okay. What we're looking for is the whole coordinate for the endpoint there, that endpoint 2. So right now we've got the x2, but we still, so that was one of our equations that we needed to make. So we just made one equation where we found the x value. How I thought it was going to do my little thing now, making it look a little bit neater. There we go. All right. And the other equation that we need to do, guys, is with the y values. All right, so again, the y value of the midpoint was -7. So again, guys, the y value of the midpoint was -7, and folks, the part of the midpoint formula that determines that is y1 plus y2 divided by 2. And so if we substitute in the part there that we do know, which is that y1 value, that value for y1 there is a 1. So that's 1 there, and we got this plus y2 divided by 2. We're going to have to do the same thing. All right, so again, guys, the equation there is really -7 equals 1 plus y2 over 2. And so we're going to have to solve that the same way that we solved the other one. Let's go ahead on and multiply both sides by 2. Both sides of the equation by 2. And again, guys, when we multiply the right side of the equation, that 2 at the bottom is going to cancel out with that multiplying 2. Because again, the inverse operation of dividing by 2 is multiplying by 2. Anyway, that's that. 2 times -7 on the left side gives us -14. So we've got -14 equals 1 plus y2. Okay? And so there, let's see here. Let's solve by subtracting 1 on both sides. y2, and again, guys, that's not y squared. That's y2 equals, y2 equals -15. So, guys, we have found both the x value and the y value now for our second endpoint, for the endpoint they were asking us to find. And guys, the final answer will be written in our xy form for that second endpoint that they were asking us to find. That x2 and y2, we have to write our answer in that form, 5, -15, in that xy ordered pair form. We have to write it like that. That's our answer, guys. That's it. Gotta go. I do hope this has been helpful to you. That's it. Bye-bye. Good night.